first hired here, she was one of the very few faculty members, men or women, that had a doctorate degree. She later said about herself, "A young lady with a brand new, unused PhD was pretty special." She was so special that when she applied with her PhD in classical literature, SPU initially offered her the job teaching PE. She accepted, but only, she said, if she could teach a Greek class, which she was given permission to do, and from that fairly humble beginning, she developed the new Department for Classical Languages, and over 40 years, she taught Greek, Latin, and inspired really thousands of students. She was also SPU's first female coach. She led athletic programs for over a decade. She actually coached the women's basketball team for a short time in the 1930s, but apparently this was pre-Title IX, because the team was split up when the church discovered that the students there were engaged in intercollegiate competition, which church rules prohibited at the time. She loved the American Association of University Women. She was president of the Seattle branch from 1948 to 1951, and during her tenure, she in the Seattle branch hosted the national convention. And she has a Weeder Endowment Fund that continues to support the Seattle branch's ongoing educational and outreach program. So truly a remarkable woman. The Weeder Annual Faculty Award Lecture was established in 1975 to honor Dr. Weeder in the year of her retirement after she had taught for 40 years as an SPU professor. The endowment to support this scholarship was given by another SPU emeritus professor, Ross Shaw, who passed away several years ago, and is still funded in part by his memorial fund. The Weeder Lecture, quote, provides a public platform from which the claims of the liberal arts in the Christian university are espoused. And each year a faculty member is chosen to receive this honor and to present, quote, scholarship informed by a Christian worldview. I think the lecture is a wonderful tribute to Dr. Weeder's 40 years of service. If she were present tonight, and I want to point out that since it started in 1975, she came to every lecture until 2001. But if she was present tonight, I'm confident she would have been thrilled to hear tonight's presentation. So I look forward to hearing it with you, and I turn the podium over to Mark.
Good evening, everyone. Thank you all for coming. I have the honor of introducing our speaker this evening, Dr. Seeley. I'd like to just start by acknowledging the fact that I'm going to list some of his accomplishments, but he's just really a wonderful colleague, so it's been a delight and a blessing to know him over the years. He earned his doctorate in experimental condensed matter physics, focusing on testing microscopic and mesoscopic models for phase changes in the nucleation of ice from liquid water. So you can say that 10 times quickly. And if you know what it means, you can tell me afterwards. He joined our faculty at SPU in 2001. He's worked with departmental colleagues on many, many grant-funded projects. He and his colleagues are wizards at bringing in just wonderful grants to this institution. And most of those grants are aimed at funding and supporting K-12 physics and physical science teachers. He's played an active role in the development of web-based diagnostic tools for physical science teachers. He's a lead researcher right now on the SPU Energy Project, a research effort aimed at studying and supporting energy learning among K-12 teachers. His current research interests include building bridges between the energy we learn about and the energy we care about, which you're going to hear a little bit about tonight. He studies growth in learners' ability and disposition to use a rigorous energy model creatively and flexibly, and understanding some of the real and perceived obstacles to student-centered science instruction. In Lane's own words, this is why he teaches physics and is so passionate about teaching physics. I believe that God created a universe which is both profoundly understandable and ineffably mysterious. Physics involves a deep search for patterns in the natural world. Through the study of physics, we see the hand of a creator who has sewn the fabric of nature with patterns which are elegant and understandable. When we keep raising and refining our questions, the elegant patterns of nature lead to novel insights and further mysteries. Lane loves to teach at a place where no questions are out of bounds, where we can freely weave together scientific, ethical, and theological ideas. Tonight, we'll have the opportunity to do just that with Lane's guidance. Lane, come on up.
Hello. Thanks, Jeff. Thanks for that wonderful introduction. Can everyone hear me? Yeah, so I want to start off by just lowering your expectations after Mark. By saying that, when I think back to proposing this lecture, because you might be interested to know that faculty put in proposals for these lectures, and one lucky person is selected, and then you get this chance to speak to you. And when I propose a lecture, I think, thinking back, I realized that I wasn't really proposing it because I thought I had something profound to say. I think I was proposing it because I think there is a conversation on environmental justice and environmental stewardship that I think is gaining strength on this campus. And I want to be part of that conversation. I want to be part of moving that conversation along. And so that's sort of why I'm here speaking to you. I hope I can do that. And I hope I can do justice to the memory of Winifred. I'm going to, in this, the theme that I really want to take up is the challenge that's presented by the science of global climate change. And I want to do that from the lens of what might our response be as Christians, and even specifically as American Christians, to that challenge. That's my perspective as a privileged American Christian. And I'm not saying that this isn't a topic that everyone has a role in. And I think for people of other faith commitments and people of other humanitarian commitments, I hope my words will also echo true in some way for any of you. But I specifically tonight am speaking out of in memory of Winifred. I'm speaking out of the Christian tradition. And so I also want to do something. There's something that you don't always get a lot of chances to do as an academic, and that is, I don't know if I'm allowed to, devote this lecture to a specific person. But I want to give this lecture in honor of my wife, Andrea, who's here tonight. And the reason is that part of what I'll speak about is 5 months that our family spent in the farmlands of eastern Uganda, trying to learn how to live as a family in a completely different part of the world. And I am so lucky to have a wife who could manage on that. Just to give you an idea, while she's traveling with her little kids and her husband in the jungles of Uganda, I was the kind of husband who would say things like, I noticed this road, it doesn't show up on most of the maps, but it shows up on this one map. And I think we should check it out and see where it goes. So she put up with that, and it will always be so privileged to have such a wonderful wife on my side. So let's get to it. I'm going to speak out of almost 20 years now of teaching SPU. That's my perspective. And my perspective is also one of spending 5 months in rural Uganda, and also one of teaching a few years now a course on global climate change, of which some of my students I can see in the room right now. And I think it's important at the outset to say that while I am going to draw on that experience, I don't want to pretend that I'm an expert on Uganda or Eastern Uganda, or poverty, or Africa. I know one little part, I know a little bit of one little part of one beautiful country in Africa. And Africa is as diverse as any continent in this world. And poverty is at least as diverse as affluence, if not more. So I hope you won't misread me as trying to say something in general about Africa or about poverty. That's not the purpose of my talk. That's not how I feel. So let's go ahead and this is where my perspective comes from. We had this opportunity to spend 5 months in Uganda. We were going there with an organization, an indigenous organization called Pilgrim Africa. Pilgrim Africa does work both in education and in community development and malaria eradication in this little town, which you won't see my laser pointer, but imagine you could. It's right there. And you would think it's only about 100 miles from the capital of Uganda, which is Kampala. But yes, that is true, but that 100 miles could take you at least 10 to 12 hours to get that distance in a car. If you think we have potholes here, you can not have potholes. So this is the experience I want to talk from. And I want to start by acknowledging an unsung hero of our planet, which is the greenhouse effect. And I think the greenhouse effect gets a little bit of a bad rap, right? But let me just put it out there. The greenhouse effect is awesome. So the greenhouse effect, for those of you who aren't familiar, is this, I'll just put it very simply, is this idea that solar radiation comes down from the sun, that solar radiation is absorbed on the Earth's surface, and then it's re-radiated out into the atmosphere. And on the way out, some of it gets absorbed by the atmosphere and then gets radiated back down, right? And that makes it more difficult for the radiation to get out, and so as a consequence, the surface temperature of the planet lowers. Simple as that. Right? And actually, there's an amazing calculation that was done not last century, but the century before that. So this was probably done, by slide rules, right? How many of you have used the slide rule? Look at Bob. So this is a calculation which basically says, what would the surface temperature of our planet be if we did not have an atmosphere? And my students did that calculation just a couple days ago, so if you have any questions, check with them. They will tell you how to do the calculation. But the answer they come up with is minus 18 degrees Celsius, which, in case you're not familiar with that temperature scale, it's a lot colder than the actual average surface temperature of our planet, which is about 15 degrees Celsius. So that's a 33 or 50 degree Fahrenheit, if you prefer, difference in temperature that results from the greenhouse effect. It's a big deal. And it's actually an underestimate. Because one thing that happens is if you take away the atmosphere, then the Earth gets icier. And when the Earth gets icier, it gets more reflective. And when it gets more reflective, its temperature goes down. So 50 degrees Fahrenheit is very much a low-ball estimate on the effect of the greenhouse. And so what we're doing now, what we've been doing, is burning fossil fuels and adding carbon dioxide to the atmosphere. And we started taking these measurements back in about 57 on the summit of Mauna Loa. Now they're taken all over the world. And what we see is really two important things. We see that the carbon dioxide is gradually increasing, and we also see that it's doing that in the same way everywhere on the planet. Right? So what this tells us is that the greenhouse effect is going to get more significant, at least when it comes to carbon dioxide, and it also tells us that the carbon dioxide that I emit right now, the carbon dioxide that went to preparing for this talk, right, is going to be spread all over the planet within a year or two. Okay? So what that means is that, from my perspective, that means the carbon dioxide that we emit, or that our lifestyles cause us to emit, not just staying here, it's affecting everybody around the planet. So, oh, and I should say, carbon dioxide is not the only player in the greenhouse effect game. Right? It turns out that there are two other things. The most important piece of the greenhouse effect is water vapor. And then there's also a significant piece of the greenhouse effect that's related to clouds. But those things, those other two pieces, are basically out of our control. Right? The only aspect of the greenhouse effect that we can control is the carbon dioxide and some other gases like methane. Right? And when we change those then will have a feedback of causing a change in the other aspects of the greenhouse effect. So what we know is that carbon dioxide accounts for about 20% of the greenhouse effect. And then we also are learning very carefully and very, over time developing our understanding of how that then feeds into the effects on other parts of the greenhouse effect. But the big picture, I think, to take away from this is it's a huge effect. And we're making really huge changes. Like this is a change of about 25% in the concentration of one of the most significant greenhouse gas that's under our control. So to think that it wouldn't change the Earth's climate would be extremely surprising. Right? It would take this sort of confluence of a whole bunch of factors to all work together in sort of strange ways to somehow rebalance the system so it didn't affect. It's just extremely unlikely. Right? And sure enough, we've been measuring. And what we find is the temperature of the surface is increasing slowly and not totally systematically, but it is increasing. So this is looking at what's called the temperature anomaly, which is basically the difference in the temperature from the sort of pre-industrial average surface temperature. And so you can see that it was sort of drifting along pre-industrially, down a little bit, and then recently it's been getting steady. 2018 is the last year on this. It came in as the fourth warmest year. So it's not a record every year, but it does seem to be going steadily up. And all of this extra energy that is stored in the Earth is being stored up in the oceans. So in some sense, climate scientists care more about where the energy goes than they do about surface temperature as sort of driving this whole process. And just to give you a sense of scale, this increase in energy of the oceans is the equivalent of about 1.5 atomic bombs per second worth of energy being added to the oceans. Most of it's staying in the top 1,000 meters or so. Okay, so, and this is another really important piece, right? I imagine many of you experienced our exciting February this year, right? You were in Seattle, okay? And this was, it's like an amazing example of the difference between weather and climate. Weather is variations that happen just over time in different places on the Earth at different times of the year, and that's exactly what we saw in February. We saw what turned out to be, you can see our February right here. We were about 5 degrees Celsius colder than the average for February. But something interesting happened. If you were thinking that because we were so much colder, the temperature of the planet was actually colder, you were wrong. Because it turns out that averaged over the whole planet in February, the average temperature of the planet was 0.93 degrees Celsius warmer than the average February pre-industrial. Right? So while we had a cold February here, the planet had a, well, you might say typical February in the time of climate change. Okay, so that's weather and climate. And what you can imagine is the thing we need to decide is not what has happened so far, but what's going to happen in the future. Right? And I want to make the case that the Intergovernmental Panel on Climate Change is the largest effort in the history of humanity to put scientists together to try to come up with a synthesis of the scientific work in an area in order to make decisions. Scientists themselves can't tell us what to do. What scientists we can do is we can try to give information on which to act, and that's what this is. This is a report that comes out now about every 6 years. The last one came out in 2014, right? Everybody is waiting excitedly for the next report, which will come out in 2020, but you'll be really excited to know that something actually was released this winter, right? Which we'll talk about in a minute. Just a kind of a teaser update report. But this comes out every year, and what they try to do is they try to put together all of the science, and then they try to predict what will happen in the future based on how we act. So, one of the things that they need to do is decide what's causing the warming that we've seen already. And this is a graphic that they came up with in the 2014 report. And what you see here is the upper line is the actual warming that we've seen over the period over basically the last 60 years, going up until 2010. And then you can see here, so we're pretty, and by the way, these are error bars, so we're pretty confident on how much warming we've seen over the last 60 years, right? This is the amount of that warming that we can attribute to the release of greenhouse gases. So what this says is there's a lot of uncertainty in how much of the warming is due to greenhouse gases, and our best guess is actually more than the amount of warming that we've seen is due to greenhouse gases. And how can it be that more than the amount of warming we've seen is a result of greenhouse gases? And the answer to that is other things happen. Or another way to say it is people did other things. One of the things we did was we released aerosols into the atmosphere, and the release of aerosols actually had a cooling effect. So what we believe, again, our best science says we had an increase in global temperature due to the release of greenhouse gases, and then we had a decrease in global temperature or an offsetting decrease because of the reflectivity of aerosols. And also it turns out that we've taken away some forests in that time, which has also made the light more reflective. The other important piece here is that our best estimate over the last 60 years is that there has been very little natural change in the source. Very little of the increase we've seen over the last 60 years has been due, at the bottom, to natural forcings and natural internal variability. Very little of that can explain the warming we've seen in the last 60 years. And I just want to make a really important point. That doesn't mean that natural variations have not caused any climate change. Right? They've caused a lot of climate change through the history of our planet. It's just that we know very well how natural systems, how things like the orbit of the Earth and the solar, the amount of solar insulation coming from the sun, we know how that's changed over the last 60 years because we've measured it pretty well. And we can say, with a pretty high degree of confidence, it turned out, that it can't have accounted for any appreciable amount of the warming that we've seen. Okay, so that's where we are. That's what we know. And one of the consequences of this warming is that we've seen a rise in sea levels. And this shows, since 1900 until about the present day, the amount that sea levels have gone up, and they've gone up fairly steadily. Not entirely due to warming. It turns out some of that's due to rebounds from the past ice age still. But what you can see is basically we've got arguably a gradually increasing sea level, and it looks like the rate at which the sea level is rising is also increasing. And you might look at that graph and say, well, but that's only about 20 centimeters, right? Get that? So 20 centimeters from 1900 until now, right, which doesn't seem like much, but I'll give you a personal example on that. So my parents live in a house that is built on pilings over Puget Sound. It was built about 1950, I think, right? And since 1950, according to this graph, the average sea level has gone up by about 10 or 12 centimeters, right? Which doesn't seem like much, but if it's in your living room, it seems like a lot. And they've seen, since they've moved there, they've seen in the last 10 years, 2 50-year floods, which starts to make you think they may not be 50-year floods anymore. But even so, my parents are not the ones who are most at risk because they have the resources. They can jack up their house. And we can, with some money, we can hopefully put them out of harm's way. But in other places in the world, as we're going to see, there aren't always those opportunities. Okay, so what I want to think about now, and you guys are probably, you're at the point in this lecture, where you're probably starting to lose some attention. So I'm going to give you a test question, all right, which is going to be fun for some of you who don't know the answer, less fun for those of you who do. So the question is, if we're going to predict how the climate is going to change in the future, we need to know something about how much carbon dioxide we're going to emit in the future, right? And two of the biggest drivers on how much carbon dioxide we've emitted in the past have been the global population and the wealth of that population. We tend to emit more carbon dioxide when we're wealthier, and we tend to emit more carbon dioxide when there are more of us, right, as humans. And so we need to know what's going to happen in the future. So here's the question. There are 2 billion children in the world today aged 0 to 15 years. How many children will there be in year 2100 according to the United Nations? And here's what I want you to do. I want you to turn to your neighbor, okay? Ask them if they know the answer to this question already, right? If they do, find another neighbor and ask them what they think. of Hans Rosling and something called Gapminder, which is a great resource. I would totally encourage you to go check it out. The thing I love about Hans Rosling, he just passed away a couple of years ago, actually I think a year ago or so. So there's Hans. He wrote a book recently called Factfulness, which explores these ideas. And I think the thing I really love about him, the thing that makes him a hero of mine, is his whole idea was give people the data. Right? Give people the information. And from there, we can start to come together and make decisions. So let's try another piece of information. In the last 20 years, the proportion of the world population living in extreme poverty has almost doubled, remained more or less the same, or almost halved. I'll give you about 20 seconds to think on it. Okay, you ready? Almost halved. We've been going down, and we're still going down. And the projections are that we will continue to go down. And we won't do any more questions, but aside from climate, this is kind of the moral of the story. There actually are a lot of things that are going really well on our planet. And we just have to think of this new big challenge that I think we have to negotiate. So let's look at that challenge. These are some predictions done by the IPCC of how much carbon dioxide we as a species will emit going into the future. Actually, it's a combination of carbon dioxide and methane gas. So total greenhouse gas emissions. And what you can see here is basically when scientists and economists don't know the answer, they just propose several different answers, right? And that's what they're doing here. They're proposing everything from, call it the red scenario, maybe call it the 8.5, but it's a representative carbon pathway. And the red is sort of if we don't take this problem seriously at all, that's more or less where we're going to go with carbon dioxide. And then the blue is if we react very significantly and very quickly. Right? So you can see that if we, in the blue scenario, we basically start reducing our global carbon emissions very soon. And then we bring them down and they actually go down to 0 by a little bit after 2050. Okay? So here's what happens according to these three scenarios. These two scenarios. So here's what happens in global temperature. Right? Global temperature under the sort of do-nothing scenario goes up by about 4 degrees Celsius, that's about 7 degrees Fahrenheit, in the next, by the year 2100. Whereas in the blue scenario, it goes up by about, it's 1 degree, on this case, above the temperature between 1986 and 2005, but that's actually more like 1.5 degree over the pre-industrial temperature. So a little detail. But the big idea here is that what we do makes a big difference in the future. Right? And the other big idea, which I think is really important to bring out, is there's a lot of uncertainties. Right? I mean, the shaded regions are saying this is the range of where it could go. And when you take that and then you track it forward into global sea level rise, you get, first you want to look at the fact that the temperature rise is not going to be the same everywhere. Right? There are places, most notably the Arctic regions up here, that are going to get a lot warmer than they were. And we're already seeing this pattern. And then there are places that won't warm up by as much. Right? So you can see that up in the Arctic, if we do nothing, we're going to have temperature rises of possibly as high as 10 or 11 degrees Celsius, which is really dramatic. And then in terms of global sea level rise, right? Here we're seeing that according to, this is not a huge difference, but according to the projections, we get about 80 centimeters of sea level rise if we take the do-nothing approach, the 8.5 approach, and then we get about 45 centimeters. That's our best prediction. But again, there's a lot of uncertainty here. Right? One thing to keep in mind is there are about 100 million people on this planet who live within a meter of the sea. And so there are a have more people. And then there will also be changes in precipitation. So you can see that in some places it'll get warmer. In some places it'll get wetter, some places it gets drier. And so I want to think about the scripture that some of you may be familiar with from Matthew, where Christ says, what you do to me, what you do to the most overlooked and vulnerable, you do to me. And I think the words in that scripture really echo for the human impacts that we now expect to see from climate change. I was hungry and you fed me. I was thirsty and you gave me drink. One of the things we're projecting is dramatic changes in food production. So, and another piece is that change in food production, according to this estimate by Klein, is not going to be uniform across the planet. There will be places like Washington State here where food production actually goes up. Right? But there will be lots of other places where food production goes down. And if you see a pattern, you notice that the global south is where the food production goes down. So it's in places where food production, where there's already food insecurity, there will be increased food insecurity. I was homeless and you gave me a room. So there was a recent, just last year, a report came out from the World Bank that said essentially if we don't take dramatic action by 2050, by the year 2050, there will be, they estimated 143 million people internally displaced from their homes by climate change. And I think it's really important to remember that what, internally displaced is not me deciding to, move to California because I can get a job there. Right? Internally displaced is the homeland, the village, the farmland that has nurtured your family that you've lived off of for hundreds of years is now no longer farmland, right? Or is now salty, brackish. And there's another interesting connection where there's this really cool study that was done where they looked at El Nino events, and they could correlate El Nino events with civil conflict. And the estimate was that about 21% of the civil conflicts that have occurred since 1950 can be attributed to these weather events, these global weather events. Right? Now, El Nino is a weather event, but this suggests that climate can also drive, in a similar way, that kind of civil conflict. And if you have sustained, remember, an El Nino event might only last for a year or two, right? Whereas climate effects will last for decades. So the potential impact on civil conflict could be really serious, which is why, for example, the US government is taking this very seriously as a national security issue. I was sick and you stopped to visit. The estimate is that we'll have, and this is a difficult thing to project, but we will have significant increases in human health impacts due to climate change. So these are things like insect-borne diseases. These are things like access to clean water. These are things like directly heat-induced illnesses. And so thinking of all this, the words of Scripture are, I'm telling the truth. Whenever you did one of these things that someone overlooked or ignored, that was me. You did it to me. And the reality that we have to confront, I think, is that it is precisely the overlooked. It is precisely the vulnerable who are going to be most adversely affected. We in Seattle have it really good when it comes to climate change. We are sort of in the climate change sweet spot, right? Because we just have a great, livable climate. We have rocky shorelines. We have wealth, right? We have precipitation patterns which actually favor more agricultural production, so it's not really our problem. Right? It's really someone else's problem. But I think as Christians, we are called to care about someone else's problem. And you probably remember the Good Samaritan, where the legal scholar questions Christ, and he says, what must I do to inherit eternal life? And Christ says, and he says that you love your God with all your passion and prayer and muscle and intelligence. This is out of the Message. And that you love your neighbor as well as you do yourself. And I remember talking to one of my colleagues that I was preparing this talk, and this is, I mean, that scripture is radical. Right? I mean, I love my kids. I love my family. I've got a whole row of family. I love these guys. But this is saying, I'm called to love my neighbor as I love myself. And then the scripture goes on and says, and Christ says, he tells the story of how this man was attacked on the road. And the Samaritan comes along. After the man was ignored by other people, the Samaritan comes along and offers aid and shows mercy. And he says, what do you think? Which of these three became a neighbor to the man attacked by robbers? And I think the thing that's telling about this story for me, and the reason why I bring it to this talk about climate change, is that, number one, this person, this traveler was someone that the Samaritan encountered in their daily walk. Right? Which it seems like I don't encounter, the people of Uganda in my daily walk. They're not living there. Right? But now, in this new reality where our lifestyle, our choices, our decisions affect the carbon concentration and therefore the livelihood of people everywhere, right? I think we live in a different place. And I think now our actions do impact people around the world. And I think they become our neighbors. But I really love the way that Eugene Peterson puts it in the Message, where he says, translates it, he says, which of the three became a neighbor to the man attacked by robbers? So it's the choice to become the neighbor, right? We have to make that choice. And I think we are now in a position as a species, and certainly as Christians, to make that choice. So here's the big challenge, and this is what recently, so there was, you may remember in 2015, there was a huge meeting of world leaders in Paris, and the amazing thing is it was possibly the largest meeting of world leaders in history, and the even more miraculous thing is they agreed to something. Right? And so they came up with the Paris Climate Accord, where countries made commitments, right? Non-binding commitments, but commitments to do things about reducing their climate impacts. And one of the things that one of the outcomes of that meeting was they gave a directive to the IPCC scientists and said, we need to know more specifically what our choices are, right? So what we want to know is two things. Is it possible to limit global warming, across the whole planet to 1.5 degrees? And what impact would that have? And what's the difference between say, 1.5 degrees and 2 degrees? Okay. And so this is kind of a complicated chart, but essentially what this says, that the big story here is, it's possible, but it's really hard. Right? Essentially, it's saying that we've got to start, here we are right now, we've been going up on this path. If we're going to limit it to this threshold of 1.5 degrees Celsius warming over pre-industrial times, we have to start acting very soon. Right? And we have to act pretty dramatically. So here's what we would have to do. They gave some different options. I won't go into all the details here, other than to say, according to this report, it can be done. It will take dramatic reductions in our carbon emissions. And in other cases, it will take significant changes in something called carbon capture. Right? But I'll tell you, in all honesty, that's the yellow one, which looks really good. That's where we go to negative emissions over here. But carbon capture, one of the things you have to convince yourself is that you can put carbon dioxide under the ground and it can stay there, which is something we definitely can hope for, but I think the near-term, much more reliable and necessary strategy to get 1.5 degrees is to reduce our emissions very significantly, very soon. And then the other part of the answer was it will have a big effect. And this, I know you can't read all this, but basically they assessed a bunch of different things and said how much, in each of these areas, how much of an effect will it have if we can do 1.5 degrees Celsius instead of 2 degrees Celsius, and the answer was it'll have a big effect. But here's a question. Look at those error bars, look at those shaded regions. Right? There's a lot of uncertainty. Right? We could act really in an aggressive way, and we still might not make it to 1.5 degrees. Right? We might come up short, even if we do almost our best. Right? So should we act? Should we act on science before that science is certain? And my answer to that is yes, we emphatically do act on science without certainty. And imagine that you were diagnosed with a form of cancer. And imagine you went to your doctor and they said, you know, we can't be totally certain, but if you take this really uncomfortable, this really aggressive combination of chemotherapy and radiation, you've got a 90% chance, according to the statistics, according to the best scientific information, you've got a 90% chance of remission. Right? I think there's no one in this room who would completely ignore that scientific evidence. Right? So when it's us at stake, when it's our personal life at stake, or the lives of our family at stake, we definitely do act. And then step into this, we're calling ourselves Christians. We're saying that we are called to love others who are most vulnerable to climate change as we love ourselves. Which says that if we would act for ourselves based on that science, then we should act for our neighbors. But there's another reaction to this, which is, well, we're not like the Samaritan. Right? The Samaritan was the only person on the scene. Everybody else had fled. Right? It was all up to him. We're in a totally different situation. We could act, and it might not be enough, because the rest of the world has to act too. In fact, all of the US could act dramatically, and we're only actually 15% of global emissions as of 2015. Right? So, should we act in the 50s? You'll be glad to know that we still are at the top of historical emissions, but in terms of yearly emissions, we're down. So should we act? And I want to say why I think we matter, and why specifically Americans matter. One of the reasons is I think that to a large degree, the world still looks at us as a model for global prosperity. Right? And we are, in terms of per capita emissions, per person emissions, we are still right at the top. Saudi Arabia is ahead, but we're right at the top, I think. Looking at the dots here. And you know, this is sort of borne out statistically too. It turns out that 16 countries surveyed thought that the U.S. was still seen as the world's leading economic power. Right? 10 think it's China now, apparently. But I think even more than that, the world sees us as a model for what it means to have the divide. Right? Here's an interview with an economic student from New Delhi. He says, "What does America mean? It means a lot of consumer products, a lot of dresses and cars and all that. A society that has more things than our society." which it's not sustainable is, I'm going to say, we have this really radical new idea, which says that we should live the entirety of our lives in a climate-controlled environment. Right? In the world, in the history of humanity, that is a very new idea. Right? And it costs us a lot in terms of emissions. Right? Air-conditioned houses all over the world takes a lot in emissions. We also have this idea, this new idea that we should eat meat at every meal. Right? I'm not saying that we should all be vegan or vegetarian, but there are shades of gray in between. Right? Now you might say, well, you're bashing the Starbucks, bacon Gouda sandwich. That's about the most anti-American thing you can do, right? And I'm just going to say, I am patriotic, right? Like when Jessica Diggins won the gold medal, the first one in Nordic skiing for the U.S., I was so proud to be an American, right? And with the Montreal Protocol, when we led the way to the Montreal Protocol, which basically has prevented the ozone hole from developing into a really serious problem, that was American scientific, world, political leadership. But I think patriotism is not just about being proud of your country's accomplishments, it's about holding your country accountable when they don't live up to the potential that they have. And so I'm not proud, and I hold my country accountable for being the only country in the world now that is pulling out of the Paris Accord. Right? Syria's in. Nicaragua's in. We're the only one that's getting it. And I think it's amazing that the words of Dr. King actually echo this kind of patriotism, which I think is relevant for a time of climate change in a way that is surprising to me, considering that he never, at this time, nobody was worried about climate change. Right? But he says the genuine revolution of values means in the final analysis that our loyalties must become ecumenical rather than sectional. Every nation must now develop an overriding loyalty to mankind as a whole and preserve the best in their individual societies. This call for a worldwide fellowship of rich neighborly concern beyond one tribe, race, class, and nation is in reality a call for an all-embracing, unconditional love for all mankind. This oft-misunderstood, this oft-misinterpreted concept, so readily dismissed by the leeches of the world as weak and cowardly force, has now become an absolute necessity for the survival of man. So, this was supposed to be the halfway point of my talk. Don't worry. My question really is as an educator, right? Well, how do we educate? What do we need to learn? What do we need to understand to take on this challenge? And I'm going to give you a challenge question here, okay? So one of the things I think we have to learn is I think we have to be very quantitatively vigilant. Because data is being thrown at us in ways that I never experienced as a kid or even as a college student. So here's a couple of examples. Right? I'm going to try to lead you down the rosy path, and then I want you to see what the problem is. Right? But both of these are deeply flawed arguments. So the one argument says that if you trace on the upper left temperature and climate, right, over the past 400,000 years, they track really nicely together. So if temperature goes up, carbon dioxide goes up. If temperature goes down, carbon dioxide goes down. Right? And so when we suddenly increase the carbon dioxide, couldn't we just use this graph? Like, why are we hiring all these scientists? Couldn't we just use this graph to predict how much the temperature is going to go up? You see the argument? You see the problem? And the similar argument is, if you look at different countries around the world, the GDP, or the income of those countries per person, tracks pretty well with their carbon emissions. So So it seems like the more carbon we emit as a country, right, the more money we're going to have as a country. So if we dramatically reduce our carbon emissions, won't that dramatically reduce our income? Do people see the error in the waves? It's one of causality, right? Imagine a car wash, right? You're running a church car wash, and you say, I've been keeping track of it, and it's really interesting, but as our water usage goes up, our profits go up, right? And then you run into this year where there's a water shortage. You've got to cut down on your water supply. Say, well, if we cut our water usage in half, then of course our profits are going to be cut in half. But that's not necessarily true, right? Because you have never before tried to cut down on your water usage. You've never stopped having hose fights. Right? And so when you do, you don't know what's going to happen. And the same is true for our GDP. We don't know. I mean, we do know that dramatically reducing our emissions will have dramatic economic consequences. But we can't, right out of the gate, say that reducing emissions automatically reduces our GDP. In fact, recent trend for the U.S. says that's not true at all. Right? Here's our emissions as a function of our income over time, and you can see that in the last several years we had this dramatic reduction during the 1973 oil embargo, where our emissions went down after that, and our income, well, it didn't go down, right? And then recently we've actually had another reduction, and it turns out that over the last 4 years, we've seen a steady decrease in U.S. carbon emissions during a period of sustained economic growth. Right? So they're not necessarily connected. By the way, the U.S. has seen the biggest reduction in carbon emissions of any country in the world since 2005. So if you want to be patriotic, by all means, we've been bringing carbon emissions down. Okay, let me give you another example of quantitative vigilance. So here, I'm graphing the child mortality, the deaths per 1,000 births, as a function of the CO2 emissions. So how does CO2 emissions impact the number of infant deaths? Which the two might be connected, because a lot of resources that depend on carbon emissions depend on or provide the health services, the transportation, the food security, all these kinds of things that reduce the number of infant deaths. And it looks like they're pretty anti-correlated, right? As we, in general, the countries that have higher emissions are also having lower child mortality. What happens when I change the axes? Because something you might not even have noticed is, what do you notice about when you look closely at the x-axis there, the horizontal axis? It's a log scale, right? Now, even if you don't remember what a log is, right, it's really good for this. It's really good at showing the spread between different quantities, where one quantity, say the United States carbon emissions, is more than 100 times bigger per person than it is for Uganda. More than 100 times. Okay, so this spreads all those countries out really nice. Watch what happens when you make it linear. The graph totally changes. Right? And not just the shape of the graph, but I would argue the moral message in the graph changes. Right? Now the new moral message is, if we look at Uganda here, which is actually doing pretty well for its income, according to this graph, if we look at Uganda, if they were to emit, say, just 1 ton of carbon more per person, they might expect, based on other countries, to significantly decrease But then you look over at the US, and you say, 1, it's not really going to matter anymore, right? We're pretty much there in terms of the resources that we need to do good healthcare, right? We might not be fully doing it, but we've got the resources. So another thing I want to say about quantitative analysis is it matters what you measure. And this is an example, something you may be familiar with, it's called the Social Progress Index. And the idea here is to try to take a holistic set of all of the economic, all of the measures we can make that seem related to the social progress of a country and put them all together into a single metric. And if you look at the list, you're going to see some you really like, you're going to see some that maybe you're not as passionate about, right? And but it's putting all of these different factors together. You can look at socialprogress.org to get more details. Some of these things are pretty easy to measure. You know, and we can all agree they're bad, like homicide rate, right? Other things are more difficult to measure, like corruption. But they're trying to figure out ways to quantify those. Because the idea here is that maybe if it matters what you measure, then maybe GDP shouldn't be the only thing we care about. And you get a really interesting graph when you look at the Social Progress Index as a function of emissions per person. So here we are with, again, the countries on the horizontal axis, we have the amount of emissions per person, and then on the vertical axis, we have the Social Progress Index. You can see that Uganda, again, is pretty low on both. But there are some surprises. Well, some not so surprises, right? Switzerland, doing pretty well on social progress, right? But look at Costa Rica. Costa Rica is doing quite well on social progress, and yet they're doing it on the cheap in terms of carbon emissions. So maybe we've got something to learn from Costa Rica. And actually, Costa Rica is an interesting case. They are, as a relatively less affluent country, they're committing to be net zero emissions by the year 2050. So how are they doing that? This is, I think, what we can learn from other countries. Oh, here's my daughter's shoe. I won't say a lot about this, but I think it really does matter, not just what you measure, but how you measure it, right? If we're getting into a new age where we're really going to be thinking hard, I hope, about carbon emissions. And carbon emissions by country, carbon emissions by state. But how do we count carbon emissions? So imagine this case, there's my daughter's shoe, right? I believe it was manufactured in Indonesia for a US company. And then it was shipped to Seattle, maybe by a Malaysian company, I'm not sure. It was purchased, right, and it may soon be donated to Goodwill, at which point it may get put in a big crate, a big container, and shipped back to, let's say, Uganda, right, to be sold in one of the resold shoe markets there. So the question is, there's a lot of different carbon footprint there. Who gets the bill? Right? And it matters. Right now, global shipping doesn't even count. Right? But global shipping is increasingly important, and so we're going to have to negotiate how global shipping will count towards carbon emissions. All right, so going back to the parable, I think another piece that's really challenging about this parable is the Samaritan had a huge advantage. Because the Samaritan was on a road that he knew very well. And he was meeting someone who he could identify with. Right? He walked that road, as far as we know, fairly often. Right? He knew it was a dangerous road. He could imagine getting beaten up on that road. And I think one of the things that is challenging for us is it's hard to imagine. It's hard to put ourselves really in the foot, in the boots of the lack of shoes, as is typically the case, of the people who are most vulnerable to climate change. If I try to think about food insecurity, right, that's a hard thing for me to really wrap my mind around, right? Because my kids I've never had a day where I didn't believe I was going to go feed my kids in the future. Never had a day of that. Right? I've never had a day when I had to worry that we were going to be displaced from our home, from the land where we grew our food, and I was going to have no idea where we were going to go next. I've never had that day. So it's really hard for me to walk on that road to Jericho, because I don't know it. But I did have some glimpses of experiences. Maybe I'll finish with a story, because I know it's already a little late. I'm going to finish with a story about my daughter, Lena. When we were in Uganda, she got sick with a bacterial infection. And it was a mysterious bacterial infection. We didn't know what it was. Right? And we tried to do tests. We tried to figure out what antibiotics might work for this thing. And she just kept getting fevers and crashing. And getting fevers and crashing. And we're going to these little clinics in this little town in Soroti. And I remember every moment of it. And I remember this woman coming in, and she was worried about her child. And she came in, and her child was suffering from malaria. And I wished my daughter had malaria, right? Because with malaria, I knew what it was. I had the money to fix it. Right? But this woman had come in from the village, and she was saying to the doctor, and I had just come out of the doctor basically telling me, what tests do you want us to run on her blood, on your daughter's blood? And I said, run them all. I mean, every test you got, run it. Because the total bill is going to be about $5. Right? This woman said, why are you charging 3,000 Ugandan shillings when the village only charges 2,000? 3,000 is about 75 cents. Right? So we were in different continents in terms of our access to healthcare. But I was in the same boat in terms of loving my child. And we drove then to the International Hospital in Kampala. And as we drove, we saw coffins. Because, unlike the United States, where coffins are carefully kept away, right? In Uganda, they're by the street side. Right? They're by the highway at the coffin vendors. And when you drive by these coffins, you can't help, especially if you drive by the coffin vendors with your daughter spiking fevers and you not knowing what's going to happen next. You cannot help but noticing that those coffins are not adult size, not all of them. They're little tiny coffins. And we got to that hospital, and the first thing that I had to do at that hospital was go to the ATM and pray that, unlike other experiences at the ATM, my money would actually come magically, electronically, from my account over in the US, from Boeing Employees Credit Union, and appear in my hand in Kampala. Because if it didn't, if I didn't have money in hand at the International Hospital, I was not going to get into the waiting room. My daughter was not going to get into the waiting room. Right? But my prayers were answered. And I took this photo. I remember going out there. This was when the fever stopped. The fever broke. And I remember going out on the porch and looking and just being so thankful. But also never forgetting that I had that little glimpse of being on the road to Jericho. Right? But mostly, I don't know what that road looks like. But there are people who do. And if I had more time, I would tell you about the wisdom of those people. I would tell you that when the people, and I'm not talking about everybody, I'm talking about the people I met. The wisdom of people who live with very little carbon emissions. And I think we have a lot to learn from them. But I'm just going to go right to my last slide. You can see a few things that we didn't quite get to. We're going to conclude with my adopted faith tradition, which is the Catholic Church and the words of Pope Francis in Laudato Si on the care for our common home. We are faced not with two separate crises, one environmental and the other social, but rather with one complex crisis, which is both social and environmental. Strategies for a solution and an integrated approach to combating poverty, restoring dignity to the excluded, and at the same time protecting nature. And I'm really optimistic. I think we can do it. I love working here at SPU with students who have fresh ideas that they're bringing to these challenges. And thanks for listening. That's a question I have to call one of my students.
We're hiding.
We have some candidates in the back.
Oh, okay.
No.
Wait, what are some of the, we're about decreasing our emissions, like,
Yeah.
what are some simple things that all of us actually do?
Yeah, right. I mean, I think that I guess here's where I would start. And I'm not saying I've started there very well myself, right? I'm not going to hold myself up as an example. But I would start with the question of what gives you deep pleasure? What things do you care about? What things make you feel whole, prosperous, and loved? And then I think when I ask myself that question, I'll just speak for myself. When I think of that, I don't think of carbon emissions. I don't think of things that require a whole lot of carbon, right? I think of spending really great quality time with people, right? I think of having a simple meal, cooking a simple meal, right? It doesn't even have to have that much meaning. It really doesn't matter in terms of my enjoyment. So I guess I would start there, in thinking about that. But then I'd also say that I think there's some sort of obvious cases where you can ask yourself, can I do with a little bit less? And one example of that I like, because I think it's a good one for all of us to think about. It also isn't a problem for me. So maybe that's why I like it. But the difference between, so flying is a big carbon issue, right? And it turns out that there's a huge difference between flying a coach and flying business class. Okay? It's like twice as much carbon, more than twice as much carbon to fly business class. And the reason is that if you build a plane with coach seats, you can put more seats in it. And if you build a plane with only business class seats, you can't put as many seats in it. So in terms of the carbon emissions per person, the carbon emissions are less than half as much for coach. Now, the lucky thing for me is being, a physics professor, I never have my, never offers to fly me anywhere in business class. So it's really easy. But I think that's an example of, even if you are offered the opportunity to do something, to ask yourself, can I do it a little bit less? Will it really take away from my enjoyment? And I think business class, if I have to try it, would be pretty great. But luckily, I'll never know.
Those minor micro adjustments, your productivity, how much would they matter? Like if we all made the minor micro adjustments?
I don't think it's about micro adjustments, to be totally honest. I think we have to make big adjustments. And if I'm totally honest, I think perhaps the most important thing is the example that we set. Because I think, as some of the wealthiest, as Americans living in one of the wealthiest corners of this country, people look to us for what prosperity means, like I said. And so I think we have to figure out how to present a better example. So, I'd like to say that my bicycle commuting is going to save the planet, but at the end of the day, I don't think it will. On the other hand, I do think, one example I was going to talk about was, so we have something, so my kids go to Holy Rosary, and I don't want to throw Holy Rosary under the bus, it's a great school. We have something very northwest called the ferry line. And the ferry line is, anybody grow up with the ferry line? Yeah, okay. Ferry line is basically everybody arrives with their kid to drop them off for school. They all get in a big row of cars, right? Almost every car has at least one family worth of kids, if not just one kid that they're going to drop off. And then, for the most part, people keep their engines idling as they wait in the ferry line and drop their kids off, right? And I think that's an example where, if you look at the same thing in Uganda, it just doesn't happen, right? We once went out to a friend's village house, and we were riding in this little tiny car. It's sort of a mini RAV4. It's a little smaller than a RAV4, right? We drive out there. We've got 4 adults and 5 kids in the car going out to the village. Have a great time out there, right? Get back in the car, we're coming back, and I do know that we've still got the 4 adults and the 5 kids, so that's good. We've also got a jackfruit, which if you haven't seen it, a jackfruit is like that. We've got a car battery, right? And then I check in the rearview mirror, and we've actually got 2 new kids. Like brand new kids. And they've got 2 chickens with them, I think. And what? Well, the chickens were ours, so they were a gift, right? And they were live, of course, because, who would give a gift with a dead chicken? But the point there is that it's a paradigm shift, right? It's a shift to thinking about not a vehicle as a way for me to get from point A to point B as conveniently as possible, but a vehicle as a way as a bunch of space that can carry people and stuff to another place. And every one of those sort of places is probably going to be filled, especially if you go to a village, because, and I once was the Uber driver, the unpaid Uber driver for a funeral. And I just kept driving back and forth. People got in my car, I took them out, brought people back, we got some, food for the funeral party, we got some concrete to build the grave, we got all these things, and the reason for all that is my car was available, and every trip was going to count. And I think I wonder how we can, because I feel like that's not a minor thing, that's like a paradigm shift, and it's shifting away from convenience to sort of a different kind of efficiency. I'm not saying that we're going to go back to that, but I think, I do feel like there's some wisdom for that. And I guess I'm encouraged, when I'm looking at kind of the college students in the room, and I'm encouraged by the next generation here, because I think, the idea of ride sharing, my kids the other day took one of those little Lime scooters. They thought that was so great, but different options. And I guess, and I'm not going to say that I'm good at this, but I think figuring out how we can not obsess so much about convenience, comfort, right? And live into sort of meaning and things that we really enjoy, but maybe are a little uncomfortable, or maybe are a little inconvenient, or maybe are a little slower, but seeking out the things that really matter. Okay.
Well, earlier on you said, the committee said, these are things that can be done, and we take the hard road
So I think the big, I'm actually, in this case, and this is where I think this should be a bipartisan issue, honestly. Because I think that the free market has a lot to contribute here. And I think as soon as we start monetizing carbon in a really aggressive way, we're gonna start to see major changes in the way we move stuff around, the movement, and we're already seeing a movement to electric cars in this country, right? But we're going to see a much quicker movement if we monetize carbon. So I think economics, I think the big thing is an economic driver of basically, and really it's simple. You're just saying that our atmosphere is not free, right? Like every other resource that a company or a person rents or buys a share of, our atmosphere should be the same, because we now know it is scarce. And I think as soon as we do that and start to use economic levers, we can see pretty rapid change. But that's really, I feel like that's really tricky. And part of the reason it's so tricky is, remember, there are all these countries that are saying we haven't had a chance to use that atmosphere yet. We've got, and we know, and by the way, and I think we can't forget how much great stuff happened with fossil fuels. Right? Like most of the advances that have made our lives really great, a lot of that good progress towards, eradicating poverty, towards lowering child mortality, towards all of these good social trends, right? A lot of that came because we had really inexpensive, readily available energy sources. And now we've got, I think, a lot of countries that are saying, it's our turn. And that takes, I think that just takes real leadership, because you can't simply just say we're going to monetize carbon and that'll be the best solution. Yeah.
So you talked about taking action in light of not identical, but clear certainty. Are there particular metrics that you can say, like, okay, there's noise over here, but if you check this box, this is a high impact way to act?
You mean personally?
So, for example, like an electric vehicle. Okay, it doesn't use fuel, but it's got all this stuff that it is embodied in it. And then we have to do something with it. Yeah. Is it a net gain? How do we know?
So, I think we can't, I guess the first thing I would say there is we can't let the perfect be the enemy of the good, right? So, I think electric vehicles, I think the good outweighs the negative, though there definitely are, significant issues with the sourcing of battery materials. But, I think one of the things I see as difficult is just that we don't, a lot of our emissions are invisible to us, right? And so we don't really know what, and that's where I kind of go back to my answer to Derek. If we significantly monetize carbon, then we would see it financially, and we wouldn't have to do all the research to try to figure out which was a better option. So, if the cost of meat, it just happens that that beef is a really big carbon footprint. It actually has a methane footprint that equivalently has a similar impact on the environment. If we were to monetize emissions and the cost of cow's meat were to go up by a factor of 10, let's say, right? We would probably consume quite a bit less. And it doesn't say we all have to, we not to all go vegan, and I'm also not, I'm not economically saying factor of 10 in beef costs, but I think that's one way to get that issue. But even there, just asking yourself, how much do I enjoy this? And then that's, to me, that's a really, I'm taking credit. Andrea's there. Oh, and I did want to, I want to give a shout out to my cousins who are here, because I think they took a really bold step. In terms of trying something, they went from a really beautiful 2,200 square foot house on Baker's Island to a 220 square foot house on Baker's Island. And 220, for those of you who aren't in the house building, it's basically, not too much bigger than the stage right here. And I think, for them it was something to try, right? But also I think it came out of their experience living in Kenya for several years. I don't know, does it?
Beautiful thing.
I mean, I admire that because I think what I see in it is they have embraced, like small things, the pleasures of, when you only have 220 square feet of living space, suddenly every square foot means more to you. Yeah, so I think we better stop it there. Yeah. Thanks a lot.
Dr. Seeley. The first one is a certificate in recognition of this talk. All right, and so there's your photo op for anyone taking pictures. Okay, let's go ahead and set that down. Because even better than that is this medallion. Any other Weeder Medallion Award winners in the audience tonight? Okay, we got a few. So you get this really great medallion if you apply for the Weeder and are selected, and you can wear it with your regalia at high ceremonies or just any time, just around the house, just to impress your friends and family.
Our students sing in class.
That's right.
They sing in class.
Wear it
You should wear it in class.
There you
My
go.
students can wear it in class.
No, you should wear it in class.
And it has your name engraved on the back, so you won't get it mixed up with anyone else. All right, so here we go. And then the third thing is a check, which isn't actually in this envelope, but we're going to pretend like it is, and that money that you're awarded for the lecture will show up in your next paycheck. So, thank you so much.